Hello friends. Hello, good morning everyone. In this lecture, photochemistry, we will going to see in detail Jablonski diagram. We already seen about the singlet state where the electrons are paired or anti-parallel, and a triplet state where the electrons are having parallel spin. Yes? Now what happens after absorption of light? Initially, molecules are present in singlet state. If we consider a Jablowski diagram here, yes, we already seen it. When molecules are present in singlet state, initially, the electrons are paired. When it absorbs a quantum of radiation, it gets excited to higher singlet state, S1, S2, and so on. This is a S0 ground singlet state. When molecule absorbs, this is the absorption. When molecule absorbs radiation, quantum of radiation, it undergoes excitation. This is the absorption phenomenon. Now, during that absorption, the molecule may go in the higher vibrational level of excited singlet state, maybe V1, V2, V3 and so on. These higher vibrational levels, they are generally unstable state. It comes to ground vibrational level called as a vibrational relaxation. This vibrational relaxation is non-radiative transition. Similarly, it may goes from S1, S2, not S1, S2 to S1. Which type of transition is there? From S2 to S1. From ground vibrational level of higher singlet state to higher vibrational level of lower singlet state. From this is the ground vibrational level, this is the higher vibrational level. This is the ground vibrational level of higher singlet state to this transition to higher vibrational level. These are the higher vibrational level of lower energy state, lower energy singlet state. Means this S2 to S1, this is called as the internal conversion. From higher singlet to lower singlet, this is called as the internal conversion. Again, there is a vibrational relaxation. It comes to ground vibrational level of this S1 state, and from S1 it may comes to ground state. These transition from higher means S2 to S0 or S1 to S0, these transitions, they are radiative transitions. There is an emission of radiations in the form of photons. It is called as a fluorescence. This is the fluorescence. What is fluorescence phenomenon? The transition of molecule from higher singlet to lower singlet. Now, when it comes to lower singlet state, there may be transition from higher singlet to lower singlet in higher vibrational level also. And during this, if we consider this absorption and emission, this absorption phenomenon is having high energy while emission phenomenon is having low energy. Means fluorescent emissions, they have low energy, low frequency than as compared to the radiations used for absorption or used for excitation of molecule. Okay, this fluorescence phenomenon stops as soon as source of incident radiation is stopped. Source of excitation is stopped because the molecules present in excited state goes to zero. Once it goes to excited state, it comes to ground state. By emitting radiation, this phenomenon is called as a fluorescence, and the emissions called as the fluorescent emissions. Okay. Now fluorescence, generally it is exhibited by all types of substances in gas state, solid state, liquid state. It may be shown by atoms, may be shown by molecules. Yes. And if this is general case, but if the absorption energy and emission energy or frequency is same, if absorption frequency or emission frequency is same, such fluorescence is called as a resonance fluorescence. If both have a same energy, if both have a same frequency, then it is called as a resonance fluorescence. But generally fluorescence is having a longer wavelength region or lower frequency region. And the intensity of fluorescence emission depends on the intensity of incident light. As intensity of incident light increases, fluorescent emission also increases. Yes, but sometimes there is a transition from singlet to triplet, means there is a change in spin of electron. If molecule is present in singlet state, means spins are paired. If molecule is in triplet state, means spins are parallel. If there is a transition from higher singlet state to higher triplet state, S1 to T1, this transition is called as the intersystem crossing, generally denoted by ISC. What is meant by ISC? It is an intersystem crossing, higher singlet state to higher triplet state transitions. Yes, and there is requirement of change in spin of electron, due to which these transitions are quite delayed transitions. It requires quite large term as compared to the fluorescence. Again, there is a transition from higher triplet state T1 to lower state S0. Yes, if we see these transitions from higher triplet state to ground singlet state. There is always singlet at when molecule is present or atom is present in ground state. Electrons are always paired with anti-parallel spin. Yes. Now these transitions again require change in spin, due to which it requires time, and this is the emission transitions. There is an emission of light when molecule comes from higher triplet to ground triplet, and this phenomenon is called as a phosphorescence. And this phosphorescence doesn't stop, it continues even after source of excitation is stopped. Phosphorescence continues, means we can generally identify whether it is a phosphorescence emission or fluorescence emission. If emission stops as soon as excitation is stopped, excitation source is cut off, that emissions are called as a fluorescent emissions, while the phosphorescence emissions, they continues even after the excitation source is stopped. It is called as a phosphorescence emissions. Okay, got it? What is fluorescence? What is phosphorescence? There are again some more phenomena, but in our syllabus only these two phenomena are included. One more point is included in our topic, that is the chemiluminescence. chemiluminescence. Luminescence phenomenon means it is the emission of light phenomenon. Yes, like fluorescence, phosphorescence, chemiluminescence. It is the emission of light during chemical reaction. There is again one more type called bioluminescence. Bioluminescence means emission of phenomenon during biological metabolism. For example, we know the firefly. There is a metabolism of luciferin, which is a luminescence phenomenon. It is called as a bioluminescence. Okay, but this is not included in our syllabus. Bioluminescence. There are more examples of bioluminescence phenomena. Emission of light by jellyfish, emission of light by firefly, and different phenomena are there. 2010 Nobel Prize in Chemistry for this green fluorescent phenomenon. Okay. This chemiluminescence is also called as a emission of light in cold condition. During a chemical reaction, cold light is emitted. Light is emitted generally when if we heat any substance, it is called as a thermal emission. But if it is not heated and still it is emitting light, called as a cold emission. Now what happens? What is meant by chemiluminescence? The emission of light as a result of any chemical reaction at our ordinary temperature. It is called as a chemiluminescence. Yes, the well-known example of this chemiluminescence is the emission of light when phosphorus is oxidized. If we keep phosphorus in air, open air, it undergoes oxidation, forms a phosphorus pentoxide. This phosphorus pentoxide formed is in excited state, higher energy state, and this higher energy state emits radiation and forms a ground phosphorus pentoxide, and this emission is nothing but the chemiluminescence. Chemiluminescence, emission of light in presence of due to chemical reaction. There are so many examples of chemiluminescence. Oxidation of some wood, decay of wood also shows chemiluminescence containing certain bacteria. This also shows luminescence. Similarly, if we consider if we add strontium chloride SrCl2 in H2SO4, there is a formation of strontium sulfate. There is a emission of light, SrCl4 precipitate is formed, which is in excited state, and there is a emission of light, glow is emitted. This is also called as a chemiluminescence. Similarly, when a mixture of pyrogalol and formaldehyde, it is oxidized with H2O2, hydrogen peroxide. Pyrogalol, mixture of pyrogalol and formaldehyde, when undergoes oxidation in presence of H2O2, it also emits radiation in the form of red light. This is also called as a chemiluminescence. Yes, got it? These are some examples of chemiluminescence. Okay, in this way here we completed a topic, photochemistry. Okay, I will share you notes of this topic as well as one or more test will be shared with you, so that you will be thorough with this topic. Okay, thank you everyone. Okay, bye.